You step outside and the air hits you like a wall. It is not just warm. It is wrong. The kind of heat that makes you squint even in the shade, that makes the pavement shimmer and your phone overheat in your pocket. And maybe you think, is this just a bad summer? Maybe you think, has it always been like this and I just forgot? It has not always been like this. And the real answer to why it is so hot right now is far stranger and far more urgent than most people realize. Here is what most people know. We burn fossil fuels. We release carbon dioxide. The planet warms. That is true. But that is the headline, not the story. The story is about physics that goes back over a century, feedback loops that are already in motion, and a window of time that is closing faster than the headlines tell you. Because global warming is not a future problem. It is a right now problem. And the heat you felt this summer was not a preview. It was a measurement. Let us start at the beginning. Not the beginning of the crisis, but the beginning of our understanding of it. In 1856, a scientist named Eunice Newton Foote conducted an experiment so simple it is almost embarrassing. She filled 2 glass cylinders with different gases and left them in sunlight. The one filled with carbon dioxide got hotter than the one filled with regular air, and it stayed hot longer. She published her findings that year and wrote, an atmosphere of that gas would give to our Earth a high temperature. She was right. She was also largely ignored because she was a woman, because it was 1856, and because nobody wanted to believe that something invisible in the air could cook a planet. 33 years later, Swedish chemist Svante Arrhenius did the math. He calculated in the 1890s that if you doubled the amount of carbon dioxide in the atmosphere, global temperatures would rise by roughly 5 degrees Celsius. He was off by a little, but not by much. Scientists today put the number between 2 and 5 degrees for a doubling. Arrhenius thought this warming would be gradual. He thought it might take thousands of years. He also thought it might be nice, particularly for people living in colder climates. He did not foresee that industrialization would accelerate the timeline by a factor of several hundred. Here is the mechanism. Sunlight enters our atmosphere as shortwave radiation. It hits the surface, the land, the ocean, your parking lot, and that energy bounces back upward as long-wave radiation, which is heat. Under normal conditions, that heat escapes into space. But certain gases in the atmosphere, carbon dioxide, methane, nitrous oxide, water vapor, act like a blanket. They absorb that outgoing heat and radiate it back toward the surface. This is the greenhouse effect. Without any greenhouse effect, Earth would average about negative 18 degrees Celsius. Life as we know it would not exist. The problem is not that we have a greenhouse effect. The problem is that we have been thickening the blanket for 200 years. Before the Industrial Revolution, carbon dioxide in the atmosphere sat at roughly 280 parts per million. That number had been relatively stable for thousands of years. By the year 2023, it passed 420 parts per million. That is a 50% increase in the concentration of the main heat-trapping gas in our atmosphere. In under 200 years, in geological terms, that is a blink. In the history of the carbon cycle, it has no precedent. So why is this summer hotter than last summer? Why does every decade seem to break records that the previous decade set? Because the system is not in equilibrium. The heat is still building. Climate scientist James Hansen, who testified before the United States Congress in 1988 and told a room full of politicians that human-caused warming had already begun, uses the phrase Earth energy imbalance to describe what is happening. The planet is absorbing more energy from the sun than it is releasing back into space. Right now, that imbalance is roughly half a watt per square meter across the entire surface of the Earth. That sounds small. It is not small. Applied across the full surface area of the planet, 24 hours a day. It is the equivalent of 400,000 Hiroshima bombs worth of heat energy accumulating in the Earth system every single day. Most of it, about 90%, goes into the ocean. The ocean is our buffer, and the ocean is warming. Here is where it gets stranger. Here is where the physics of this crisis becomes almost difficult to look at directly. The warming we have already caused has set off what scientists call positive feedback loops. Positive here does not mean good, it means self-reinforcing, a change that makes itself worse. There are several happening right now simultaneously. The first is sea ice. Arctic sea ice is white, highly reflective. It bounces sunlight back into space instead of absorbing it. As temperatures rise, ice melts. Where ice melts, you get dark ocean water instead, which absorbs far more heat, which raises temperatures, which melts more ice. Researchers at the National Snow and Ice Data Center have documented that the Arctic is warming roughly 4 times faster than the global average. The feedback is already running. The second is permafrost. Across Siberia, Alaska, and northern Canada, vast stretches of permanently frozen ground contain organic material, dead plants and animals from thousands of years ago that has been locked in cold storage. As that ground thaws, that organic material decomposes. Decomposition releases methane. Methane is a greenhouse gas roughly 80 times more potent than carbon dioxide over a 20-year period. We are not in control of this feedback. It is not waiting for a political decision. It has already begun. The third is water vapor. This one is subtle. As air warms, it can hold more moisture. More water vapor in the atmosphere means more heat trapping, which warms the air further, which allows it to hold even more moisture. Water vapor is the most abundant greenhouse gas on Earth. It is also invisible, so it rarely gets discussed. These loops are not happening independently. They are happening simultaneously, and they interact with each other in ways that make the system genuinely difficult to model precisely. What climate scientists can say with certainty is that these feedbacks make the situation worse than the simple equation of more emissions equals more warming would suggest. The system has momentum. It has inertia. Even if we stopped emitting carbon dioxide tomorrow, temperatures would continue to rise for decades as the heat already trapped in the oceans slowly works its way into the atmosphere. This is not pessimism. This is physics. But here is what is also physics. The same properties that make this system slow to cool down make it responsive to intervention. The feedback loops that amplify warming can, in some cases, be slowed by reducing emissions. The ocean that stores heat also stores the carbon we emit, though at a cost to its chemistry. Every fraction of a degree of warming avoided is a real outcome with real consequences for real people. The difference between 1.5 degrees Celsius of warming above pre-industrial levels and 2 degrees is not a rounding error. It is the difference between coral reefs that survive in a diminished form and coral reefs that effectively disappear. It is the difference between hundreds of millions of people facing water scarcity and billions. The heat you felt when you stepped outside this summer did not come from nowhere. It came from a century of accumulation. It came from every combustion engine, every coal plant, every cleared forest, every concrete city that replaced a grassland. It is thermal physics operating at planetary scale, and it has a name, a cause, and a trajectory that scientists understand with extraordinary precision. What it does not have yet is a full response proportional to its scale. Catherine Hayhoe, an atmospheric scientist at Texas Tech University, often points out that the most dangerous thing about climate change is not the heat or the floods or the storms. It is the normalization, the way each new record becomes the new baseline, the way we step outside into air that feels wrong and we shrug and we go back inside. You felt the heat this summer. You were not imagining it. You were not being dramatic. You were measuring something real, something cumulative, something that started long before you were born. but that is arriving now, unmistakably in the air between you and the sky. The next time you step outside and the heat hits you like a wall, you will know exactly what that wall is made of. And knowing what it is made of is where every solution begins. Every week we open a new file, a new truth about why humans feel, think, and act the way they do. If you want in, subscribe. The next one might change how you see everything.